Yes. Now coming to sulfur. Sulfur was known to the ancient Indians, Greeks, and the Romans rather. Sorry, due to its frequent occurrence in the free state in the nature. Alright. Its elementary nature was first established by Lavoisier. Lavoisier first established its elementary nature. So sulfur occurs in the native state, in the free state, as well as in the combined state. Alright. In the combined state, we are getting in the form of copper pyrite, Cu2s, iron pyrites, FeS2, zinc blend ZnS, cinnabar HGS, galena PbS, sulfates like MgSO4, Epsom salt NgSO4.7H2O, globus salt Na2SO4.10H2O, barytes BaSO4, we can say that, gypsum CaSO4.2H2O. In this way, so many we can get it. And also in the volcanic gases, sulfur is also being present in the form of hydrogen sulfide, we can say that. Now sulfur we are extracting by the Frask process. We are extracting sulfur by the Frask process. In the Frask process, what we do is that we are taking three concentric pipes, alright, and these pipes are put into, that is, bed, and the sulfur, it is being found inside the earth's crust in from the surface of the earth at 125 feet depth. Sometimes sulfur is also found at 500 to 1000 feet depth, also it is being found beneath the inside the earth's crust. So therefore it is almost impossible to extract sulfur by ordinary mining techniques. So it has to be done by this particular process only. So we are taking 30 centimeter diameter pipe is first, concentric pipes we are taking it. There is three pipes are there. So from the outer pipe, what we do is that from the outer pipe we first pass superheated steam. We pass it from the outer pipe at a temperature of around 455 Kelvin. So from the outer pipe, and from the inner pipe we pass hot compressed air. So by passing superheated steam, what happens is that the sulfur melts under the very high temperature. Sulfur melts, and by passing through hot compressed air, what happens is that the pressure is created, and the molten sulfur is no more remaining in that particular sulfur beds. It comes out from the middle pipe in the form of sulfur froth, we can say that. In the form of sulfur froth, it comes out from the middle pipe, we can say that. So this particular process is called as a Frask process, by which we prepare sulfur, we can say that. Now the sulfur, what you can say is that sulfur we are getting it by this particular process, which is 99.5% pure, and it may be further purified by distillation, we can say that. It is pale yellow in color, brittle and solid crystalline in nature. It has faint smell and a marked taste, we can say that. It's a poor conductor of heat but a bad conductor of electricity. It has no psychological action on human beings, but it is poisonous to lower organisms, we can say that. It exhibits the phenomena of allotropy, we can say that. It has got several allotropes. We are having several allotropes of sulfur, we are having is that. Sulfur exhibits a very unusual behavior on heating. Unusual behavior. When ordinary sulfur is heated, it melts to form a pale yellow mobile liquid. Then after that, this on heating further, this mobile liquid on heating, the pale yellow mobile liquid becomes thicker and more viscous on further heating. Alright, it becomes more thicker and viscous on further heating. Alright, at the same time, its color changes from pale yellow to dark brown, we can say that. Got it. On further heating, its viscosity starts decreasing and it becomes increasingly more mobile. See, it is how what you can say, the first it becomes viscous, then again from the mobile state it becomes viscous, and again it becomes viscous, but again it becomes freely mobile, we can say that. Got it. So how unusual behavior sulfur is having, and that is nothing but due to the puckered ring of 8 atoms. Puckered ring means a crown like structure. I have discussed with you earlier also. That is, it forms a crown like structure. The 8 atoms of sulfur forms a crown like structure. Crown, the crown means the king the wears the crown, जिसको मुकुट बोलते हैं हिंदी में. So that sort of structure it forms. 8 sulfur atoms joined together to form a puckered ring, Puckered, puckered ring, which is forming a crown like structure. When the sulfur melts, these S8 atoms ring slips and roll over one another easily. That is why sulfur, the pale yellow liquid formed just above the melting point, is mobile and can flow easily. We can say that. Clear? Now sulfur, what you find is that on burning in air, it forms sulfur dioxide. It forms sulfur dioxide when it burns in air. Got it? And sulfur combines with many metals and non-metals to form several compounds. Like it combines with metals to form FeS, with mercury to form HgS, with carbon, that is non-metal, to form CS2, with phosphorus P2S5, with arsenic AS2S3, with hydrogen it forms H2S, with chlorine it forms S2Cl2. Got it? So there are different allotropes of sulfur. We can say that we are having rhombic sulfur, we are having monoclinic sulfur, we are having plastic sulfur, we are having milk of sulfur, we are having colloidal sulfur. Rhombic sulfur is the most common and most stable form of sulfur. It is called alpha sulfur or octahedral sulfur. Alpha or octahedral sulfur. It is pale yellow in color and its melting point is around 385.8 Kelvin. It is insoluble in water but soluble in carbon disulfide. Monoclinic sulfur, it is called beta sulfur or prismatic sulfur. Beta or prismatic sulfur. It is prepared by melting sulfur in a dish and cooling till crust is formed. We can say that the crust is pierced by needle and the liquid below is taken out. On removing the crust, transparent crystals of monoclinic sulfur is obtained. We can say that. Monoclinic sulfur, noted this one, this is very important, is stable only above 369 Kelvin and changes into rhombic sulfur below this temperature. Again I repeat, monoclinic sulfur is stable only above 369 Kelvin, which is a transition temperature, and changes into rhombic sulfur below this temperature, so to say. Alright. Now, however, the crystals of monoclinic sulfur differ from those of rhombic sulfur in symmetry. Plastic sulfur, it is also called gamma sulfur. It is prepared by pouring boiling sulfur in cold water. Alright. When plastic sulfur is obtained, it is soft rubber-like amorphous mass. It possesses no sharp melting point. It is insoluble. It is soluble neither in water nor in carbon disulfide. Plastic sulfur consists of an open chain structure. Open chain. Milk of sulfur, when flowers of sulfur are boiled with milk of lime, that is CaOH whole twice plus S, will give you CaS5 calcium pentasulfide plus CaS2O3 calcium thiosulfate plus water. Calcium pentasulfide CaS5 plus CaS2O3 plus HCl will give you CaCl2 plus water plus sulfur. Again I repeat, calcium hydroxide plus sulfur will give you calcium pentasulfide CaS5 plus calcium thiosulfate CaS2O3 plus water. CaS5 plus CaS2O3 in the next step plus HCl will give you CaCl2 plus water plus sulfur. This is your milk of sulfur, which is soluble in carbon disulfide. Alright. It is widely used in medicines, this particular sulfur, we can say that. Now colloidal sulfur, colloidal form of sulfur may be obtained by passing hydrogen sulfide through nitric acid or by treating sodium thiosulfate with dilute hydrochloric acid. H2S plus HNO3 will give you H2O plus NO2 plus S. H2O plus NO2 plus S. Na2S2O3 plus HCl will give you NaCl plus SO2 plus H2O plus S. We can say that. Colloidal sulfur changes into ordinary sulfur on heating or on keeping for a long time. Alright, colloidal sulfur. So in this way we are having alpha, beta, gamma, milk of sulfur and colloidal sulfur. These are the different allotropic forms of sulfur. Now coming to sulfur dioxide, which you can see it on the screen, that is the action of concentrated sulfuric acid on carbon or sulfur or copper, we can prepare sulfur dioxide. You can see on the screen that second equation, copper plus sulfuric acid will give you copper sulfate plus sulfur dioxide plus water. Similarly, Na2S2O3 on heating with sulfuric acid will give you sulfur dioxide plus Na2SO4 plus water. Similarly, FeS2 plus oxygen will give you Fe2O3 and sulfur dioxide gas, you will be getting it. Okay, in this way you get the sulfur dioxide gas. Sulfur dioxide can also be prepared, you can see here, that is copper, which I was telling you. We take concentrated sulfuric acid and we take copper, that is chips. Concentrated sulfuric acid is poured from the thistle funnel and in the round bottom flask, and we get the sulfur dioxide, which is being collected in the gas jar, we can say that, by the upward displacement of air, because sulfur dioxide is a heavier gas. It is being collected in the gas jar. Got it? And air is lighter than sulfur dioxide, it is being replaced. Alright, in this way we are getting, that is sulfur dioxide, so to say. Clear? Now that is sulfur dioxide is a colorless gas having pungent and suffocating smell, we can say that, and it is poisonous in nature. It is heavier. I already said it is soluble in water. Sulfur dioxide, it forms sulfur dioxide and is known as sulfur dioxide water or sulfurous acid, we can say that. Sulfur dioxide, it burns with magnesium and potassium to form the respective oxide, like Mg plus SO2 will give you MgO plus S. Potassium plus sulfur dioxide will give you K2S2O3 plus K2SO3, we can say that. Clear? Now calcium hydroxide reacts with sulfur dioxide to form calcium sulfite. This calcium sulfite, when it is passed through excess of sulfur dioxide, it forms calcium bisulfate, we can say that. Excess of sulfur dioxide, it forms calcium bisulfate, we can say. Clear? Excess when it is being passed through. So in this way sulfur dioxide acts as reducing nature. Sulfur dioxide reacts with water to form sulfuric acid and nascent hydrogen. These nascent hydrogen decolorizes acidified potassium permanganate, also decolorizes acidified potassium dichromate also. Got it? It decolorizes acidified potassium permanganate as well as dichromate. Sulfur dioxide acts as a bleaching agent also. It bleaches colored leaves, colored flowers, fabric dyes, vegetable matters, we can say that, because sulfur dioxide bleaches by reduction. When sulfur dioxide reacts with water, it forms sulfuric acid and nascent hydrogen, so it bleaches by reduction, and hence it is what you can say, temporary in nature. Temporary. Alright, so bleaching of sulfur dioxide is temporary in nature, that is, it can regain back its color on standing in air for a long time. On standing in air for a long time, it can regain back its color.